All right, this is part two of our solubility graphs. I kind of split our lecture into two parts because I know there's going to be some people that just need a little help with the solubility graph. So rather than having to go through all of part one, I figured I'd just split it up into the second part. So what I want to talk about now are solubility graphs. Now remember, graphs are visual ways that we can represent data. In terms of a solubility graph, it helps us indicate the solubility of a substance over a range of temperatures because the max amount, how much we can dissolve, varies from substance to substance, but it also varies from one temperature to another. So it's an easy way for us to figure out what the solubility of a substance is. It's a line graph of solubility versus temperature. Solubility is our responding variable, which is found on the y-axis. Temperature is our manipulated variable. That's going to be on our x-axis. So that tells us what the solubility of a substance is. But the last thing that a solubility graph can tell us is if a solution is saturated, unsaturated, or supersaturated. So let's take a look at the graph that you got here in class. So what I have here is I have a solubility graph of three substances, and I'm going to highlight them right now. We have a line for potassium nitrate, we have a line for sodium nitrate, and we have a line for sodium chloride. Now, I will highlight those lines. So for potassium nitrate, we have our yellow line, which is right here. Excuse me if I run off the graph here. All right, for sodium nitrate, I'm going to highlight that so we can kind of correspond which substance that is. And for sodium chloride, which is down here at the bottom, we have there. So what these lines are telling us, here we see we have temperature down here at the bottom. We see that's our manipulated variable, and our temperature ranges from 0 degrees Celsius to 100 degrees Celsius. On our y-axis, we have our solubility. Notice this is given in grams per 1,000 cubic centimeters, but hopefully you recall that 1,000 cubic centimeters is equal to 1,000 milliliters, and 1,000 milliliters is equal to a liter. So we can essentially say our solubility is given in grams per liter. And I notice, again, for every substance, the amount that I can dissolve changes. Now, please realize, this is all for 1 liter of water. So I can see for sodium chloride at 0 degrees, I can dissolve approximately 380 grams per liter in 1 liter of water. But if I crank up the temperature to 100 degrees, I can dissolve a little bit more, maybe about 400 grams per liter of water, and that's for sodium chloride. But for something like potassium nitrate, in 1 liter of water at 0 degrees, I can only dissolve a little bit above 100. We'll say maybe about 120 degrees in 1 liter of water. But if I heat that water up all the way up to 100, now I can dissolve 2,400 grams per liter. So in that same volume of water, 1 liter of water, I can dissolve almost 24 times the amount of potassium nitrate in that 1 liter of water. Sodium nitrate, same thing. I see at 0 degrees, I can dissolve about 700 grams per liter, but when I crank it up to 100 degrees, now I can get a little over 2 times the amount, maybe almost 2.5 times the amount, with 1,800 grams per liter. And that varies from one substance to another. So these are what we refer to as our solubility graphs or solubility curves. And again, it's telling us how much is dissolved, or what's the maximum amount I can dissolve in 1 liter. Now, let me clear this out. And we're going to focus mainly right now on sodium nitrate. So I've highlighted that there in pink. Now, one of the other things I mentioned about solubility graphs is having the ability to be able to decide what state our solution is in, if it's saturated, unsaturated, or supersaturated. Now, to determine that, I still need to know our solubility, and that's what these lines are for. These are my solubility curves for every temperature ranging from 0 to 100 degrees. The other thing I need to know is my concentration. Now, that would be something I would calculate. So let's just say, for example, I'm going to dissolve, why don't we say 1,400 grams of sodium nitrate in 2 liters of water. Now, first thing I need to do here is I need to figure out what that concentration is. So I'm going to take 1,400 divided by 2, and I'm going to get 700 grams per liter. And we'll say it for this example, our temperature is at 40 degrees Celsius. So that's the temperature that I'm dissolving this in. So what I need to do is I need to look on my graph. I need to find where 700 grams per liter is for my solubility. I need to find where 40 degrees is on my temperature. So I see that 40 is right here. I see that 700 is right here. So I go where the two meet, and I find that my concentration is right there. So I've just indicated that by the pink dot. Now, when I look at that position relative of my concentration relative to my line of solubility, I see my concentration is below that line. Anytime I have a concentration that falls below my solubility curve, I say that I have an unsaturated solution. So pretty much anything in this region that I'm going to color here, anything below that curve, anything here, I can consider that to be unsaturated. So I would be, in this case, if I had to ask what would be the state of my solution if I dissolved 700 grams per liter at 40 degrees, since it falls below the line, it would be an unsaturated solution. Now, what if I took that same solution, and now instead of dissolving 700 grams per liter, I actually went in and I dissolved 1,000 grams per liter at 40 degrees. So now I look to find my concentration, and I see that it falls on the line. Now, since it falls on the line, and any concentration that falls on the line, that would be considered what we refer to as a saturated solution, because I've essentially just dissolved my maximum amount. Now, the next step, a lot of people say, oh, well, that means if I am above the line, I must be supersaturated. Now, that's only partially true. If I do let my solution dissolve and I've heated it and cooled it back down, yes, it would be a supersaturated solution. So if I found that if I was able to get, let's say, 1,200 grams of sodium nitrate to dissolve in 1 liter of water at 40 degrees, and my concentration found here, yes, it would be supersaturated, but only if it's completely dissolved. And I'm going to put that here, completely dissolved. If I would just add, and that's again, that's only if I've heated it up and cooled it back down. If I tried to add 1,200 grams of sodium nitrate to a liter of water at 40 degrees, and I did not heat it up, I did not cool it back down, I just plunked it in there, I would only have a saturated solution, which essentially means only 1,000 grams of my sodium nitrate will dissolve. The remaining 200 grams would just fall to the bottom. So don't automatically assume that if I figure my concentration to be 1,200 grams per liter, don't automatically assume that it's supersaturated. It needs to be heated, it needs to be cooled, it needs to be completely dissolved in order to be supersaturated. If not, if it's just put in and mixed, then it would only be considered a saturated solution, and the remaining went down to the bottom. Excuse my typo there. Now, this is all for 1 liter. What if I needed more? What if I needed less? What if I needed the same concentration but with a different volume? Well, I would need to make a ratio. Let's say I know that I have 1,000 grams can dissolve in 1 liter of water at 40 degrees. What if I wanted the same concentration but in 2 liters of water? Well, I would set my solubility, 1,000 grams per liter, and now I would say I don't want it in 1 liter, I want it in 2 liters. So I'm going to say X amount of grams in 2 liters. Well, now I can cross multiply, and I'm going to get 2,000 grams per liter equals X amount of grams per liter. And from there, I can find the volume of any solution I want for the same concentration, but other volumes other than 1 liter. So these graphs can tell us a lot about solutions. It can tell us the state of solutions. It can tell us how much we can dissolve, and it can tell us if we make a saturated solution, how much will fall down to the bottom. So I hope this second part of the video helps you with your homework and helps you through the next few days with our labs.